Welcome back. Last time we introduced NPY files and the npsave function. This time, we'll see how to store data via npsaves and discuss another file type native to NumPy, npz. This new function works best with multiple arrays. So, just like last time, let's begin by importing the lending company saving CSV file. In the interest of saving time, we can just copy the code we used earlier. For our second array, we can load the NPY file we created with the npsave function in the last video. Perfect. Syntax-wise, npsaves is identical to the npsave from the last lecture, so we can copy and paste the code from earlier, where we saved the lending company variable. After that, we just add the z to the name of the function, and we're good to go. Unlike its counterpart, npsaves doesn't create an npy, but an npz. The npz is like an archive of npys that can store multiple arrays. Hence, instead of storing different datasets in separate npy files, we can store all of them in a single npz. This is extremely convenient and can be very useful when working with large amounts of data. For the purpose of this exercise, we can also add lending data save as an input of npsaves. As we saw last time, these two arrays are identical, but we'll simply use them to examine how the function works with multiple arrays. All right. Next up, we want to load the npz we just created. The syntax here is identical to what we did with npsave, so you can reuse the code and change the name of the variable, and switch file extension to npz. Now that this is done, let's print out the variable. We see an interesting message talking about an npz file object instead of the actual datasets. But why is that so? Well, that's because the npz file contained a collection of arrays. Therefore, it can't be properly displayed this way. To solve this, we must specify the array we want to open. For example, if we want the very first one, we indicate ARR_0 in quotation marks between square brackets. This syntax tells Python to pull the array with index 0 from the lending data saves variable. Without getting into too many details, Python uses 0 indexing. So array 0 refers to the first array we stored in the npz, which contains the lending company data. This time, we see a 2D array as an output, so everything looks all right. Similarly, if we want to display the values of the second array in the archive, we write ARR_1, and so on. This is because by default, the npz file stores each dataset as a separate array with a generic name. If we want to set distinguishable names for each one, we do so by defining keyword arguments for each array. So, let's go to a new cell and paste the code where we created the npz file a few minutes ago. Since both variables include lending in their name, we can call the first dataset company and the second one data save. To achieve this, set company equal to lending company. And similarly, data save to lending data save. After creating a new npz, we should reload it into Python once again. Then, after saving and loading the data anew, we can refer to the files attribute to check the names of each file inside the npz. As expected, we see that the names are company and data saves, exactly what we wanted. This is great because we no longer need to use the generic array 0 and array 1 notation when we refer to each file. Great! Now that we can refer to each file with these new names, let's go to a new cell and display their contents. Just copy the code where we printed array 1 and change that to company and run the cell. Next, we want to print the second dataset, so we'll switch company for data save. It looks like we obtained the same output both times. However, let's verify if both arrays of the npz are identical by executing the npArrayEqual function in a new cell and passing both rows as inputs. The output says true, so we know the data remains the same even after saving and reloading it back into our code. Fantastic! Now that we know what the NPZ files and the npsaves function are all about, we're ready to store data in text files. Next time, we'll examine the npsavetxt function, which saves files in more traditional text formats. Thanks for watching.